evening and welcome to Tinkering with Edkelar. I spent the last weeks between making my Nabu PC modem prototype and my day job obligations, as well as mowing the lawn for the first time this year. Oof. So for this episode, I have another smaller device on the stage, a Heathkit IT28. Watchers who also follow Mr. Carlson on his channel will recognize the box. One of these makes an appearance with him every now and then. It is a tube-based resistor and capacitor bridge, so you can measure resistors and capacitors to a rather accurate degree. I did restore an impedance bridge before, so you might be asking, why? And while the bridge feature is certainly useful, I mainly got it for the leakage tester. It will load the capacitor with the proper high voltage and check if there is any DC current flowing, or if the capacitor is leaking. These pop up on eBay now and then, and I really got lucky on this auction. The package arrived with a slight whack on one edge, and that seemed to have caused a bit of damage in transit. Bummer. If you send something with stick-out buttons or sockets, always put on some firm padding to protect them. The backside of the case looks scuffed up quite a bit, but the front panel looks almost brand new, other than the bent binding post and some grime. Nice! The dropped package made me fear for the condition of the tubes, but nothing sounds like broken glass inside. Only some metal clonk sounds. Oops, the mains transformer is holding on by a thread. Literally. The nuts were both just on the screws, not even finger tight. If that had come undone in transit, there would have been much more damage than just the tubes. Phew! The tubes are indeed all in one piece. I'll check up on them later. That rectifier looks a bit bad on the inside. The front panel looks good, but could use some deep cleaning. All the insides seem to be covered in some residue? Did somebody try some oil-like spray as a contact cleaner maybe? The two large electrolytic caps look dodgy. I'm not even bothering to use them as is and see if I have suitable new ones. And indeed, got two proper ones on hand even. I desoldered one resistor from the voltage selection switch, which was essentially holding the two parts together without the front panel, and the mechanical stress could have snapped it. I cleaned all the switches. The usual heavy black soot was on all of the contacts, and also the two potentiometers. The grease inside them got quite stiff, and at times it made for spots with bad contact even. I would have loved to take apart the switches a bit further, but they are peened over in the resin board. I think this assembly would cause permanent damage here, so I'll clean them as best as I can as they are. The case parts cleaned up quite nice. Specifically, the binding posts are now all shiny again after a bit of wire wheel action. Attaching a new power cord. I love these lamp cords. They sure aren't designed for this use, I know, but they look period correct to me. putting the panel back together and reconnecting that one resistor. When I took off the caps, I saw that one of them had a slight pimple on the case that looked a bit sus. Might that be the reason why the inside is covered in goo? The new capacitors fit in well enough. I only had radial ones at hand, but they are small enough to be wired in towards the chassis, so that works out. Also, I put some tubing over the legs to prevent shorts. These are across B+ after all, which is 600 volts in this case. Now to give it a try. Again, I first start without any tube to check the transformer output. Off screen, I did a test on the tubes. All three of them check out below acceptable range, so I ordered a set of newer ones online. The I-tube is getting rather rare, but the others are still pretty common. Next, adding the rectifier tube and nothing? Wait, why did the fuse blow? Humph, that original tube seemed to have completely died on me between the tube tester and now. Oh well, replacement is already here. Checking B+. All good, right around 600 volts. So, time to add the other tubes. And again, with the old ones, not much is visible. The I-tube is completely worn out, to the point that I can just so make out a dim glow when I turn off the lights. So, new one it is then. Ah, much better. This is how the 60 is intended. So, on to the calibration procedure. After making sure that the bridge balance potentiometer is properly centered, I'm moving on to the leakage tester. It has 3 trimmers for each of the capacitor types. Circuit time! The overall idea is to put the capacitor against high voltage DC derived from the B+ line via a resistor network. No need for it to be extremely precise, ballpark is good enough. Then, the calibrated trimmer will see any current flowing across that capacitor. Initially, of course, there will be quite a bit. But once the capacitor is charged, it should drop down to 0. Current across the resistor, or trimmer means voltage, and that voltage is used to close the eye-tube with the amplifier, so even a minute voltage and current can be seen. If everything works out, the eye-tube should open up completely after a short burst of charge time. If it doesn't, there is leakage current. Plain and simple. The adjustments are quite accurate. The paper mode detects currents of only 2 microamps as faulty, at any voltage. The electrolytics is satisfied with 2 milliamps. After adjusting these trimmers with the help of accurate current measurements, I give these 2 old electrolytics a test. Turns out that they are about 50 microfarad instead of 40, which doesn't sound all that bad, but they are rated at 350 volts, so I tried a leakage test. I don't dare to go full voltage on them right away, so I start low and work myself up. And yes, at about 150 volts, the eye already doesn't open up all the way. Oof, really bad. I think the standards for the lower capacitor ranges are out of whack too. Indeed, after desoldering them and putting them across my other bridge, they are over 10% out, with a nominal 2% tolerance. I am putting in a few caps in parallel to match the nominal value as close as I can. 200 picofarad and 20 nanofarad are not common these days, and these caps are the reference for the bridge. And in case you worry about the voltage, the bridge runs at 12 volts, nothing to worry about. The bridge uses an internal generator of 50 Hz for the AC measurements, which is just the filament voltage stepped up again to 12 volts. It does have input for an external generator and can take up to 10 kHz that way. You can also connect an external standard, i.e. external reference value, and that would also allow for inductor measurements. I do not know why they didn't add that into the unit. The range switch could easily hold another 1 or 2 notches. And that's it for this episode. I hope you enjoyed this vintage gear. See you next time, maybe for another Nabu PC update. Good evening and welcome to Tinkering with Edkelar. I spent the last weeks being... well, we're off to a good start, aren't we?